A silent rulebook shapes the sky, yet nobody is in charge. Space keeps order with local rules, not a boss. Galaxies, rings, and orbits emerge from countless tiny pushes and pulls. Nothing coordinates them, yet patterns appear and persist for ages. The core rules are gravity, conserved motion, and feedback from energy. Gravity gathers matter, conserved motion stabilizes orbits, feedback prunes extremes. Those three ideas explain most structure you see with the naked eye. Think of a crowded sidewalk where lanes appear without planning. Each person follows simple habits and a flow emerges. Space does the same, only with stars, gas, and dark matter. Spiral arms, ring gaps, and stable orbits prove it with clarity. One sentence recap: local physics adds up to grand cosmic order. Those rules will show up in every pattern you notice. Start inside a cold cloud of gas, quietly adrift between stars. A gravitational collapse is mass attracting mass, faster as density increases. This matters because every star, planet, and comet begins in such clouds. Here is how the balance builds from simple pushes and pulls. Gravity draws material inward, while heat and pressure push outward against collapse. Motions randomize through countless close passes, like a bumper car rink. The inward pull strengthens as density rises, so speeds increase as well. Eventually, a balance emerges where motion counters gravity on average. Astronomers call that state virial equilibrium, a calm that still jiggles. Energy trades between particles, yet the overall size barely changes. Example in real terms: a cluster of 1,000 stars stabilizes within a few million years. Its radius holds steady, even while stars weave intricate paths. Gas leftovers drift away, leaving a bound swarm that endures. Net result: many tiny encounters create a stable crowd without supervision. Now stand beside a star, watching a small world sweep its path. An orbit is continuous free fall that curves perfectly around a focus. It matters because orbits prevent chaos from decaying into constant crashes. Here is how motion stays on track, even over vast times. Gravity bends the path inward, while momentum keeps the object moving forward. Together, they set a speed that locks shape, distance, and period. Angular momentum resists sudden changes, like a flywheel hidden in space. In near vacuum, there is almost nothing to drain that motion. Example you know by heart: Earth circles the Sun in 1 year at 30 kilometers per second. Mercury runs faster because it is closer and deeper in the well. Miss the required speed and the object escapes or falls inward. Rule of thumb: energy decides whether you loop, skim, or fly away. Bottom line: conserved quantities act like steel rails for celestial traffic. Lift above Saturn's rings, where etched lanes and gaps look hand-carved. A resonance is a repeating gravitational nudge, delivered on a strict beat. This matters because tiny rhythmic tugs can shape chaos into crisp edges. Here is the relentless play that sculpts order from a noisy disk. A moon lines up with certain ring particles at the same phase. Each pass adds a kick, while mistimed passes cancel and fade. Particles migrate until the drumbeat weakens, then a sharp boundary freezes. That boundary is a lane divider, written by timing, not by walls. Example with numbers: the Cassini division sits near a 2-to-1 beat with Mimas. Asteroid belt gaps align with simple ratios to Jupiter's year. Trojan swarms gather 60 degrees ahead and behind Jupiter's path. So the picture is rhythm and timing carve structure without a director. Drift across a star-forming galaxy, pocked with bubbles and shock-bright rims. Feedback is energy a system feeds back into its own source. It matters because unchecked collapse would burn through gas far too quickly. Here is the loop in action, across scales from stars to cores. New stars ignite, then blast winds, radiation, and supernova shock waves. That push heats surrounding gas, raising pressure and stirring turbulence. Collapse slows, so star birth eases and the push fades. Gas cools and settles, inviting the next burst of formation. Supermassive black holes run a harsher loop in galaxy centers. Accretion lights disks and launches jets that heat entire halos. With little cool gas, new stars struggle to form for eons. Example with a scale: supernovae release about 10 to the power of 44 joules. X-ray maps reveal cavities tens of thousands of light-years wide. Net result: galaxies regulate themselves like thermostats, cycling between feast and fast. Step back to the deep pattern of everything, a lace of filaments. The cosmic web is a vast network of strands, sheets, and hubs. This matters because galaxies gather along this skeleton, not in random clouds. The growth starts tiny, then compounds under the patient pull of gravity. Minute ripples in density grow as expansion stretches space between ripples. Dark matter collapses first, building halos that trap gas in their wells. Gas cools along filaments, then streams into halos where it can condense. Collisions and shocks ignite stars where the traffic piles into nodes. Example with scale. Filaments span hundreds of millions of light years, bridging giant clusters. Surveys and simulations agree on those sizes with striking precision. You can even see walls like the Sloan Great Wall in maps. What to remember, large-scale order emerges from growth on a scaffold. Drop into a single star cradle, laced with dusty strands and knots. Interstellar magnetic fields are invisible lines that guide charged gas motion. This matters because fields and turbulence decide which knots can become stars. The choreography is physical, not mystical, and it leaves sharp fingerprints. Turbulence shreds clouds into dense clumps and wide, low-density voids. Magnetic tension steers flows along field lines, like rails underground. Gas slides where resistance is lowest, then piles at magnetic pinch points. Once densities cross a threshold, gravity grabs control and triggers collapse. Example in real terms. Polarized starlight traces field directions across entire clouds. Protostellar jets align with those same directions, straight as arrows. Star formation efficiency stays low, only a few % per free fall. Bottom line, structure in the gas regulates its own next moves. Swing past a banded world where storms weld into spots that outlive kings. Entropy measures disorder overall, and the total always increases. That sounds fatal for order, yet patterns bloom where energy flows through. Here is how an open system makes shape while spending fuel. Sunlight pours in as low entropy power, then leaves as diffuse glow. In between, turbulent fluids rearrange into lanes that move heat efficiently. Bands, cells, and vortices form because they carry energy more easily. The flow becomes organized while dumping excess disorder into the void. Example with numbers. Jupiter's Great Red Spot spans over 15,000 kilometers across. Zonal jets wrap the planet in belts that circle the globe. Similar cells stack in Earth's atmosphere, driving deserts and rainforests. Net result, rising entropy still allows strong, long-lived organization in flows. Dive toward a black hole, where a bright disk whirls and a jet spears outward. An accretion disk is orbiting gas rubbing itself into heat and light. It matters because that light and those jets reshape whole galaxy neighborhoods. The chain of cause and effect is tight and brutally efficient. Friction shares angular momentum outward, so inner gas spirals down and heats. As heat builds, the disk brightens and strong winds peel mass away. Magnetic fields twist and launch jets that punch into the halo. Those blasts keep halo gas hot, choking the next round of feeding. Example with scale. Some radio jets run hundreds of thousands of light years long. Quasars can outshine their hosts by billions of times in power. Star formation drops by factors of 10 in quenched galaxies. So the takeaway is, engines regulate the very fuel that powers them. Return to the night sky, quiet, wide, and richly patterned. No council meets above the stars, yet order repeats everywhere you look. The rulebook stays local and simple, yet produces sweeping structure. Gravity collects, conserved motion stabilizes, and feedback prunes runaway growth. Resonance carves lanes, fields guide flows, and energy builds neat patterns. We began with a web that looked designed, almost suspiciously tidy. Now the rules are visible in every lane, gap, and spiral. There is comfort in that clarity and also a deep wonder. If this reframed how you see the sky, stay a little longer. I post calm explainers on space, physics, and hidden order. Subscribe if you want the next quiet dive to meet you here. Final thought, space keeps order because every small local push adds up.